If you come to any business school, you will be advised to do the exactly opposite. That's why we see so many companies, as small and big, launch new plant-based products trying to substitute animal versions. These products are very well welcomed by the customers who lean to more and more healthy products. Combined together, the variety of new products plus the demand from customers resulted in 20% growth of the plant-based category. And this is surprisingly huge compared with just 2% growth for all other foods. And what's important for us, this demand for the plant-based products created the demand for the plant-based ingredients and created an opportunity to upcycle what's previously fed to animals. Now, vegetable oil extraction plants, well, as many other food processors, can valorize their byproducts. Instead of $160, $200 that they get for the metric ton of their byproducts, they can get $1,100 if they repurpose it for the human consumption. And during this webinar, we will tell you what are the options do we have. But first, let me tell you how we started. 5 years ago, we were a team of food scientists who formulated and sold nutritionally complete drinks. We were a CPG company, and we were quite successful. We sold over 1 million of servings of our products. And thinking about how to grow further, we started sourcing ingredients for newer formulations. And there, and the specifics of our business, we don't see the ingredients as the meat or apples. We see the nutrients behind those ingredients. And one day, we stumbled on sunflower oil cake, dry matter left after oil was extracted from sunflower seeds. And what caught my attention? It was extremely cheap. I used to pay $5,000 for the metric ton of soy protein, and here I was asked just $200 for the same metric ton. Wait, 5,200. Oh, well, I was very interested to use that source of protein for my cost optimization. But it was hard like wood chips, and the protein isolation was not so effective. So the only option the vegetable oil extraction plants had is to feed to animals. But isn't it ridiculous to feed to animals more protein, 35% to be exact, than we get back from beef? So circling around this byproducts, we eventually figure out the way how to upcycle that. And then we thought, well, if we turn it into the flour, then we can pass savings that we oversaw for ourselves to significantly more companies that can use it to substitute their all-purpose flour. So we did this, and right now we love our business because you don't need to grow more crops to provide ingredients, consume more water, and repurposing it from the animals, you reduce the greenhouse emissions. And look at the nutritional profile. The flour from defetted sunflower seeds, it's not higher than other upcycled ingredients, but it's 3 times more protein than in regular all-purpose flour. Having the dark appearance, it provides the artisanal look for many products. It's like the brown rice flour and white rice flour. And those applications taste great as bakery, so pasta, so meatballs. Moreover, having the high protein content and the high fiber content than the regular all-purpose flour, it allows to convert the baked applications that were never considered as the good source of protein into the good source of the protein and fiber. And customers love it because initially we had the big prejudgment question: will they actually eat it? So we had to manufacture the chips from our ingredients and launch it on the Amazon to test the demand. And our chips were featured on ABC. Today's dietitian recommended us. National Sunflower Association that's we endorsed us. But I can actually continue this for a long time. But let me actually play the video, and you can hear by your own ears what customers say on the product made from the upcycled ingredients.
It does look like a brownie, but it tastes like a delicious, spicy chip, and I love it.
I really can't believe that it has more protein than meat. But it does.
It had a nice airy texture, and it had a nice spice to it. I love it. I absolutely love it. Stretch is excellent.
Barbecue is amazing. We really like it.
Very delicious.
I like the cinnamon.
I kind of like the sweet one the best.
Yeah.
Cinnamon.
What I love about these is that they're dense and flavorful, and it's not like eating a chip. It's like eating a small, like a dense cracker that's super tasty. Super tasty, right? It is.
Okay, so okay, I can listen this for years, but let's get back to the technology. Let me pass the microphone to James and tell you more about the process. James, are you ready?
I'm all set. Thanks, Ale. And you just saw Ale standing in front of the test system at the University of Minnesota there. So basically, the key secret to all of this is using the extruder for multiple purposes. So the extruder is used at a high enough temperature to achieve multiple logs of kills of pathogens. It also destroys myco and aflatoxins. And lastly, I think most importantly, the flash expansion at the die breaks the cell walls and liberates the trapped cellular components, including the proteins. So here you can see just a little picture of that. And here are some COA comparisons of the product before and after treatment. So you can see the various pathogens that you test for, and then also the negative aflatoxin on the resulting product. And basically, you can see it just knocks everything down. So texturizing. So the extruder, as we were just showing, it makes actually the interesting crisp, but the majority of our customers are not really interested in this. They're looking for the flour that's made from milling down these crisps, and that's really the big opportunity, I think, for us and for you with the market. So looking into the flour, there's a number of products in the in adjacent spaces already out or coming out soon. We're kind of a unique solution with the sunflower meal compared to what they're doing. Specifically, we are still inexpensive and allergen-free. Plus, we offer more nutrition than others in the space. And we're not concentrating the protein, so we save on all the extraction and isolation costs, which, you know, we've all seen pictures like this, but it ends up being, you know, way more than the cost of the good to actually manufacture it. So so our next topic is how to distill this down to practice. From a basic process flow perspective, the meal is unloaded from whatever transfer system is bringing it over to the extruder, because generally it's thought that the extruder will be in a different part of the plant. So we made sure that we accounted for that. Then, because the dryer is probably also sitting separate from the extruder, I threw in enough money, or I threw in a pneumatic conveyor into the capital project, and then finally added a mill and a super sack bagger to get the product, which is 100 mesh, ready for shipment. So looking at let's break this down into actual brass tacks costs. So I arbitrarily picked a system size that does 3 metric tons per hour. There are systems out there that do far more than that. There are systems out there that do far less, but this is a basis of design. So given that the unit operations are slightly out of order here, but based on experience, these systems are all similarly sized for capacity, and I've spec'd out these types of equipment in the past. And so these are the numbers that I pulled in. If you've got a challenge to one of these numbers, feel free to edit it in your own. Go back a slide. Feel free to edit it, but these numbers are inclusive of tax and freight and installation, but doesn't include any contingency. So would recommend that you guys apply a contingency number that's compliant with your organization standards as you look at these numbers. Just trying to be completely transparent on where these numbers came from. And then we also took this 2.5 million and straight line amortized it into the variable costs. So I alluded to the variable costs. Here are the costs that went into this, determining the cost per metric ton for the product. So this is a processing line at a crushing plant. We'll look at a local aggregator on another slide here in just a minute. We use the current rate in the U.S. for raw cake, which is $160 per metric ton. We padded in the labor force pretty heavily here. Threw in a good holder for utilities, maintenance, overhead, and quality, and packaging as well. So when you roll all of that together, you end up with a total cost of $264 per metric ton. That includes the current price of $160, which is basically what the opportunity cost is for pursuing this. You'd have to give up that $160 per metric ton in order to divert to this stream, plus $104 in invested processing costs, inclusive of everything else on this slide. So at the end of the day, that 264 is inclusive of the 160 and the 104. And when you look at the value of this versus wheat flour, which is what we hope to pin our initial pricing to, of $1,100 per metric ton, that's an increased value for the product of $836 per metric ton. So that's not bad. There's another model for this as well, looking at the next slide here, where you'd use a local waste stream aggregator. This is useful for regions that grow many different types of crops, but only harvest 1 or 2 crops at a time. Or another concept would be to involve those that process crops into packaged goods, which also generate waste streams in this case. So when I say local aggregator, I'm talking about, we ran the math for within 50 kilometers or 100 miles. Not that it really changed all that much. So on the next slide, we throw that transportation cost in there of 50 kilometers. If you wanted to go further outside of that, you could add the incremental cost there yourself to determine whether or not you still get a decent ROI. But as you can tell, it didn't really change the math all that much. So it's pretty decent there. And with that, I'll pass it back to Ale to talk about the demand for the product itself and how things are going with our commercialization efforts.
Thank you, James. Yeah, we showcased our ingredients first time on the IFT last summer, and initially we wanted to just offer the protein at the price of the flour. And if you saw the calculations, you see that we actually can make this. But speaking with our customers, speaking with distributors, we realized that we may charge it even higher. Because more based on the protein parameters, we're very close to the soy flour. But unlike the soy flour, we are non-GMO, allergen-free, and sustainable. And these claims add extra value to our ingredients. So for now, we price it for 1,100 per metric ton, so slightly less than the soy flour. It's higher than wheat flour, but it's twice as less as the chickpea flour that considered right now as the healthy alternative on the market of the functional flours. And look at the number of companies who are interested to substitute to the their all-purpose or wheat flour in their applications. It's the list of the big names, but right now that's actually more than 46 companies. It's already around 70. And some of them pretty fast. We are very happy to have Barilla, who not only tested our ingredients, but also committed the investment into our company, along with Amadori and Finiper. Amadori, this is the European manufacturer of the meat products, and you will see the application that we made with them. So actually, to the word about the applications. So we, based on the sensory characteristics and the protein fiber nutritional characteristics, we chose the target categories. You may see here that the savory snacks being a $110 billion market, morning goods, breads, sweet biscuits, pasta and noodles, meat products, and spreads, puree, and dips like hummus. These are all other applicable categories. You maybe don't see here the protein drinks. That's true because of the fiber. As you remember, we not extract the protein. We decided to keep everything. And the fiber still inside of our ingredients. So we are not the best application for the liquid products, but for the semi-liquid products, for the baking applications, we are great. And then we applied the following logic to estimate how big is the potential market. So we thought that the cost of the goods in the retail price is maximum 25%. So, and the bulk ingredients, like the flour, it's up to 50% of them. And to keep the same texture, keep the same taste as the customer used to, we suggest to replace 30% of those ingredients. And if we multiply these numbers, we get the ratio that we can apply to every market category. Not for every product. It's 30%. For instance, for the extruded snacks, the chips that we demonstrated, so it could be up to 70%. In our chips, we had it 66%. So in some categories, it could be lower. So we multiply it on the minimum and maximum recommended substitution. And we got the these numbers in billions as the potential market for the upcycled ingredients. And at this moment, you may think, well, maybe it's a big numbers, but let's verify it. We looked at the total flour market, and then look at the functional flour market. That's for the flour fortified either with protein or with fiber or other nutrients. And if we put here numbers from the previous slide, 17 up to 43 billion, it looks like we are good to go. So we have our niche, especially if we go beyond just the sunflower. Our technology, as you already learned, works with multiple byproduct streams. And then we asked ourselves, okay, this is just the theoretical practice, but do we have application that we can showcase and say it works? And this is this images of the applications that we tested either in our lab or with our partners like Barilla or Amadori. I will not stay here for a long time. We have a specific webinar dedicated for the brands who use our flour as the ingredients. But you can see here and chips and muffin and pancakes and even croissants and breads and buns and pizza crusts, as well as cookies and biscuits and pasta and noodles. And we demonstrated how it behaves and matches the same characteristics, as well as crackers, hybrid meats, meatballs, and the hummus-like applications. And for all of them, we calculate the claims, good source of the fiber, good source of the protein, to provide our customers the right to put such claims on the packages. So let me once again list the primary applications for our technology based on the highest protein content. We like to work with oil cakes, and it could be any type of the oil cake that grows in your area. It could be byproducts of the sugar manufacturing. It should be grains, distillers, or the breweries. And as well, that could be other byproducts that, if you're interested to play, suggest send it us for the tests. Well, as you understand, all those products upcycled from the feed applications for the food markets require the GRAS certification, and we are in process of getting the GRAS certificates for our ingredients. But if you think about what if I have the unique byproducts, now let me tell you. So the majority of the byproducts comes from the edible sources. So it was, even if it's a potato peel, it's also edible. So the process in the United States for the self-affirmative GRAS certification, roughly 3 months. And if you want to get the non-objection letter, so it's a plus 6 months. In Europe, it's a little bit longer, up to 18 months, but it's feasible. We are going through that. Now, let me tackle a couple of questions regarding the sustainability, because the majority of our customers think about the sustainability of their supply, and this is not a buzzword. This is right now comes into the their P&Ls as the thing that they thoroughly calculate. And when we upcycle what's right now fed to animals, that actually provides with the extra ingredients for them to feed the growing population. Because if they feed, for instance, oil cake to chicken, and then we consume chicken, we get only 17% calories from the initial 100%. If we feed it to swine and consume pork, it's just 9. And near 3% if we feed to cows and consume the beef. While upcycling those byproducts, we preserve 100% initial calories. And as we already know, it's the protein and fiber. We also have the life cycle assessments showing that the upcycled ingredients, since they are already grown, so they require significantly less land, water, greenhouse emissions. So, or you may add it to all your marketing materials if you are going to sell it to the customers. So, to summarize, so what's right now costs 160 can be sold for the human consumption at the price of the all-purpose flour for 1100. So it takes 2.5 million of capital costs, but if you already have the extruder and you can repurpose for that, it may be cheaper for you. The conversion costs around 100. So it's a technology that can process huge amounts. So starting from the 3 metric tons per hour and up. So let me stop on this and ready to answer your questions. Okay, let's look what questions do we have. You may type your questions here in the upper right corner. And so let me shoot you a couple of questions that we already have. James, can you comment? What's the minimal reasonable volume for the processing?
You know, when you look at what to fire up the system and to actually get it going and everything like that, I would say, honestly, you want to be processing at least a metric ton of material, or else it's really not going to be worth it to even turn the system on with what it's going to take to get it all set up and primed. It'd be better if you could go for, say, 3 metric tons. But if you're looking at a minimum to really turn it on and get it going, I would say about a metric ton of material.
Okay. So another question, it's what kind of support do you provide if you work with the new ingredients?
I'm sorry, say that again?
What kind of the technical support are you capable to provide for the facility that wants to upcycle the new stream of byproducts?
Sure. So we've got connections with obviously multiple equipment manufacturers. I've worked with a number of these groups over the years with Del Monte and Campbell Soup and whatnot. So we've got the relationships. We can do it as simple as introductions and handing off existing quotes, all the way through to if we really want to get down to it, working with local site support to find the best place to put equipment, process flow, working with connecting different utilities and things like that, all the way through to I think our best value add is at startup support and commercialization. So I think that's really where we add the most value, but we can work with you all the way back if you'd like with the right project scope.
Okay, can you comment once again on the capacity? So that's for the estimated plant with the capex 2.5 million. So
Sure.
what is the daily capacity? Can you multiply these 3 metric tons per hour?
Yeah. So I took time out of the in the assumptions to subtract out for breaks and things like that. So I did 6.5 hours per shift, 3 shifts. Times 3 metric tons an hour. So, when you multiply all that out, that comes out just short of 60 metric tons a day. So when you're talking about daily capacity, that's what I would go with. If you have less material being generated per day for that, I would just cut back on the number of operational hours rather than trying to turn down, scope the system down. So if you're targeting, say, 50 metric tons a day, I just turn the system down a little bit and run it less hours rather than trying to scope it back down, because it's always easier to turn the system back up should you have more throughput through your plant through expansion efforts or optimizations. But it's a lot harder to add capital for an incremental 10 to 15% of capacity. So just trying to think ahead about how you do that. So that's the answer to that question there.
Thank you, James. And we are approaching already to the end of our time. So let me ask you the last question. What would be the best first step for those who are interested to license our technology?
Well, I obviously want to learn a lot more before we even get into licensing discussions. So please just shoot me an email or give me a call. I'd love to chat with you about what the right solution might look like for your plant. But I wanted to at least present the information today for the example of a typical installation, just so that people have it as a benchmark item to go up or down from based on their actual needs. So yes, reach out to me as step one, and then we'll engage you and work with you from there.
Perfect. Thank you, James, for the co-hosting the webinar. So thank you, everyone, for attending. So you will get the link to the replay right after the webinar is over. So thank you very much. Have a nice rest of your day. Bye-bye.
Great. Thanks. Bye-bye.